1/10ths for side lengths and to the nearest degree for angle measures. Remember, we never round in the middle of a problem. Okay, remember that's why we put the asterisk on these. We make sure that in the calculator we put the whole big long decimal. We don't round until the very end when we're getting our answer. We had 3 different setups where we would use law of sines. If you had angle, angle, side, which you could also call side, angle, side, side, angle, or angle, side, angle. Okay, those 3 scenarios, you have enough information to do law of sines. The last one, the angle, side, angle, you would have to do the angle sum theorem first to find your third angle, and then you could set up law of sines. Okay, but if these are not your 3 setups or the pieces of given information, you don't have enough information to do law of sines, what are you to do? Okay, so on the back side, we have the law of cosines. Okay, so these formulas, there's more formulas here. It's not as simple. It's not just a proportion. But luckily for y'all, you don't have to memorize the formulas. You will be given the formula on the test and the quiz next week. So here we're going to use okay. It's different formulas depending on what you're trying to solve for. So if it is a missing side, okay, so to find a side length, you're going to have the side that you're looking for. So we'll just say, let's say you're looking for side A. Okay, that side squared will be equivalent to the other 2 sides squared and added together minus 2 times both known sides times the cosine of the angle across from the side that you're looking for. Okay, in this case, A. So this can be rearranged, rewritten for if you're not looking for side A. What if you're looking for side B? Okay, so it would be B squared. And then the 2 known, if you're looking for B, if B is missing, you must know A and C. So it would be A squared plus C squared minus 2AC. And then the angle that you're taking cosine of across from side B would be angle B. That's the angle you would have to know. Okay, so if I wanted to find side C, what would this one look like? How would I write this formula? Very good. Okay, so you don't have to actually know all 3 different versions because it's not always going to be A, B, and C as the vertices and sides of your triangles. It could be X, Y, Z. It could be QRS. It could be any letters, right? It doesn't matter. It's just the side that you are looking for, the unknown side squared equals, and then you have the sum of the 2 known sides squared minus 2 times the product of the 2 known sides times cosine of the known angle, the angle opposite the side you're looking for. So let's visualize that real fast. In this first example, I'm going to sketch a triangle. There's triangle ABC again, so we'll label it ABC. They tell us that side B is 12, side C is 20, and angle A is 40. Okay, and they ask us to find side A. This is what we want to find. Okay, Does this fit the bill to be able to use this information? To find side A, I have to know both other sides and the angle opposite. Is that what I know here? Okay, good. So this is the situation when we would use one of those formulas. So how would you write this as far as like SSA, ASA, what would you say? This is side, angle, side. So SAS. So this was not one of the ones that SAS was not here for law of sines because it's not enough information to set up a proportion, is it? Because you don't know anything across from each other, angle or side. So we can't use law of sines. So SAS is one of the situations when we will use law of cosines. Okay. So we're going to use law of cosines to find side A. So I'm going to write that formula here again. So it's b squared plus c squared minus 2bc times cosine of A. Okay, then I'm going to plug in what we know. We know that side B is 12. Side C is 20. Angle A is 40. Okay, what mode should my calculator be in? Okay, so I'm going to make sure I'm in degree mode. Okay, which I am in the scientific, DEG is showing. So 12 squared plus 20 squared minus 2 times 12 times 20 cosine of 40. All right, that was a lot of typing. That's a really big number. Do you think that looks right? Looking at our triangle, if we have a side that's 12 and 20, does it seem right that our third side would be 176? Okay, so what do you think the thing is? What is it, Frank? Yeah, it's because we haven't solved for A completely. This is A squared. Okay, so what do you have to do to get rid of that squared? You have to take the square root. So your options here are to go ahead and write out your decimal. And you can just put like dot, 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 like it's a long decimal and show, okay, you have to take the square root of that like this. So you can do it in 2 steps like that. Or if you realize I still am going to have to take the square root of this, you can do it all at once. You don't have to do it in multiple steps. You could just come up here and say, okay, I've got to get rid of this square root here. Oops, let me get my pen back. I got to get rid of my square root. And you could put all of that under the square root and type that all in at once and knock it out. So I don't care if you do it all at once or if you do it in multiple steps. That's up to you. Okay, but hopefully if you are doing it in multiple steps, you'll make the connection. You're like, wait, that doesn't look right. Oh yeah, I'm not done. So then you take the square root and you type in or copy and paste in that entire decimal and get your answer. Or you do the square root of all of that all at once and you get that same answer. Does that make sense? So you have a choice there. I'm going to copy this over for our notes. It looks like in the calculator. All right. Copy. All the way to the other side. Cool. Down to where we are. Sorry, I don't know why it took it to the front page. Okay, here we go. All right, so there's your options for how you can plug that in the calculator and how you can write it out. So you can write out in 2 steps or all at once. Okay, so here it is in 2 steps. Here it is doing it all at once. Your choice, either way. A comes out to approximately 13 point, and we're going to thousandths. So that's going to round to 278. So far, so good? Okay. Now, I know this only said solve for A, but let's go ahead to kind of review what we did yesterday. Let's go ahead and solve for the triangle. So let's go ahead and solve the rest of what's missing as well. Okay, so we found side A, good to go, yes. Now that I know A, I need angle B and angle C. What could I do? Now that I know A and angle A, what do I have enough information to do now? Now I have enough information to do law of sines because I have an angle and the side across from it. So now I have, I could do law of sines to finish out and find these other two. Now I have to make sure I'm careful and because this is a decimal and I want to make sure that I use the entire decimal and not the rounded one. But I can go ahead and finish this out by doing law of sines, which is what we went over yesterday. So I'm going to find angle B. So that would be sine of angle A was 40. Side A is this 13 point, and I'm going to put dot, dot, dot. So I remember I got to type it all in, not just these 3 digits after the decimal, but everything that's in the calculator. Okay, B is my unknown. And then side B is 12. Okay, so I've got it set up. And so I cross multiply and divide. I'm going to continue my work over here. So that would be sine of B is 12 sine of 40 over the 13 number, right? Everybody good with that? When I calculate this, is that my answer for angle B? What do I still have to do? Anytime, yeah, take the inverse. Anytime you're looking for an angle, you're going to have to do inverse trig. The inverse is always going to be the what you have to do for an angle that's missing. Okay, so when I find angle B, I'm actually going to have to inverse sine all of that. So let me pull up my calculator and take care of that. So I have my 13 number in the calculator that I'm going to have to use. Instead, I should put my dot, dot, dot there. Dot, dot. Okay. So I'm going to do inverse sine. I'm going to do it all at once. So inverse sine, and back to the main keyboard. It is 12 sine of 40 divided by, and then I need to copy in that big long 13 number. There's that answer. Okay, now yesterday I told you, and at the beginning of the notes I reminded you, for side lengths we're going to thousandths, but what are we going to round to for angle measures? Yeah, I'm just going to the nearest degree, the nearest whole number. Down here. Oh, well. Okay. So B comes out, angle B, to approximately 36 degrees. Now, if I have angle B and I was given angle A, what should I do to find angle C? Where my writing go? Weird. Like all my writing that was there is gone. That's strange. Okay, whatever. If I know angle A and B, how can I find angle C? Yeah, I can just go back and use triangle sum theorem. Okay, so I'm going to come back up here. Okay, and I'm going to use triangle sum is 180. So I've used 40 and then 36 is what we said, right? That's 76 degrees we've used. So that leaves us with 104. So angle C is approximately 104. I'm going to kind of number my steps here. I did this first. And then I came down here and did this. And then I came up here because I had space to write and did this. So I did solve that triangle. I found all the missing pieces. You'll feel okay about that? So there will be some problems where you have to start with law of cosines, but then you'll go back and use law of sines. Okay, so you may end up using both. So far, so good? All right, let's draw this next triangle. It says find the largest angle of a triangle whose sides are 9, 12, and 18. We know nothing about the name of it, the letters. We get to pick that. Okay, do y'all want to stick with ABC or do you want to call this something else? Good? Just sticking with ABC? And it doesn't matter which ones you label A, B, and C. So just be consistent with mine so that your answer is correct. Because if I switched it and I did A at the top, that would change what sides were what, right? Okay, so here, this would be side C, this would be side B, and this would be side A. Let me actually go over those numbers in color. So that was 9, 12, and 18. So what do I have here as far as given information with S's and A's? What do I have? Side, side, side. Okay. Now, if I have side, 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 are one of these formulas going to help me? It can help me, not the way that it's written, right? I'd have to do a lot of working backward, but there's an angle here. If I know A, B, and C, couldn't I find angle A? Okay, but instead of having to completely work this backward every time, I'm going to go ahead and give them to you solved for cosine of A, B, and C. So if I were to do all of the algebra to rearrange this to get cosine of A by itself, so these are to find an angle. You can go ahead and rewrite these in this format. So if it's angle A that I want, I'd isolate cosine of A, and it ends up being B squared plus C squared minus A squared over the 2BC. So essentially, whatever angle it is that you're looking for, you're adding the square of the two sides that are not across from it and subtracting the square of the side that's across from it. See how the A's match? A is the one subtracted. And then dividing by 2 times the product of the two that were added up here. So if I wanted to rearrange this other one, if I was looking for angle B, it would be A squared plus C squared minus B squared over 2AC. And if it was angle C I was going after, it would be A squared plus B squared minus C squared over 2AB. So again, those are the same formulas as these, just rearranged. So you don't have to do the working backward, all those steps every time. You have them written out both ways. If it's a side that you're looking for versus if it's an angle that you're looking for. Okay, so I'm going to go down here and I'm going to add side, side, side to my list of when I can use law of cosines. Okay, so side, side, side. Okay, now I'm gonna solve the triangle, but I'm gonna first find, it says the largest angle. So they want us to find the largest angle. I'm gonna find all three for the sake of our notes, but we'll find the largest one first. How would you identify, instead of finding all three and then looking and saying, oh, this one's the biggest? Before I find any of them, can you tell me which one's the biggest? How? The biggest angle will be across from what? The largest side. So which of those sides is biggest, 9, 12, or 18? So it doesn't really matter how you labeled this, okay? If you switched your 9, 12, and 18 around, we just need to know that the largest angle will be across from 18. So the way that I labeled mine, that's going to be angle B. Does that make sense? Okay, so I'm going to find angle B first. So I'm going to use cosine of B would be A squared plus C squared minus B squared over 2AC. Okay. Now the okay, so this is the formula we're going to use, and you may have, if you labeled yours differently, like if you switched your A and C, that's not going to affect it because you can multiply them or add their squares and you'll get the same answer, as long as it's the B, the 18 that's being subtracted. So that's going to be cosine of B. So it'll end up being 12 squared plus 9 squared minus 18 squared. And again, the 12 and 9 can be switched because when you add them, you get the same sum. And when you multiply them, you get the same product. Okay, so as long as it's the 9 and 12 here and here in either order, and that the 18 squared is what's being subtracted. All right, so that is going to give us actually real quick, before I clear this out of the calculator, I just want to point something out, remind you of something. When you were working this one and we plugged it in and you got this 176 number before we took the square root, that should clue you in that that's not a realistic number for our answer. Okay, if we have a 12 and a 20, it's impossible. Not only does it seem way too big, it is in fact way too big. It's impossible for those three sides to form a triangle. Do y'all remember in geometry, the rule that says two sides of a triangle have to add to be greater than the third side? Okay, so 12 and 20 add to what? So there's no way side A could be 32 or larger. It has to be less than 32. So if you remember some of those rules about triangles, some of those facts that you learned back in geometry, they just help you make sure your answers are realistic. Okay, so your answer here had to be less than 32 to be possible. Otherwise, the triangle, the two sides would never meet. It wouldn't close. So hopefully, because this is a common mistake, is to do this and forget to take the square root, forget to do that extra step. So hopefully seeing those kind of outrageous numbers and remembering those rules will help you realize, wait, that doesn't make sense. Oh yeah, I need to take the square root. Okay, so I just wanted to point that out real quick before I clear that out of the calculator. All right, so over here now, for this one, we're going to do 12 squared plus 9 squared minus 18 squared. Now that is just your numerator. You are welcome to do your numerator, get an answer. Denominator, get an answer. Divide them, get an answer. Like you can break this down into multiple steps. If you don't want to break it down into multiple steps, that's fine. But if I try to hit divided by now, it's only going to put my denominator under the 18 squared, not the entire thing. So if you want to do it all at once, you have to put the entire numerator in parentheses to get it all up there together. Does that make sense? So we've got that in the numerator, and then the denominator is 2 times 12 times 9. Now, oh, I did not mean to put a plus there. Hit enter. Does that number make sense for an angle of a triangle? A negative 0.458? Well, one, it's really small, even if it was positive, and two, it's negative. Okay, the angle measure of your triangle cannot be negative. What do you think we need to do still? Look at your equation over here. That's cosine of B, we just found. So it's not angle B, it's not B alone, it's cosine of B. How am I going to get rid of that cosine? I have to inverse cosine of all of that, of this decimal. So remember on the keyboard, you hit the function button and you get your inverse trig buttons. So inverse cosine of all of that. So you can do this again, just like the last one, in 2 steps, get that decimal and then take inverse cosine. Or if you are good and you want to just do it all at once, you can do inverse cosine and then type all of that in, and you can see you get the same number. So I don't care which way you do that, as far as in 2 steps, in 4 steps, or all in one. That's up to you. Yeah, so if you realize I'm gonna have to take the inverse at the end, you could just do it before you type all this in the calculator. So you could type in inverse cosine and then type in your fraction here. And you can see that gets you the same answer. Let me copy that in over here. All right. So there's that one. So that comes out, we are rounding angles to the nearest degree. Oops. So this was angle B. Comes out to approximately 117 degrees. And that is the largest angle. Now I'm going to go ahead, we're going to solve the triangle. So we're going to find the other two missing angles, but you need to know to be able, if it asks for the smallest or the largest or something like that, you can do that without finding all of them. Okay, but for the sake of our notes, we're just going to do the rest of this to make sure we understand how we would do it. So now that we know an angle, I have enough information to set up law of sines again, don't I? And that's easier than, I think, doing law of cosines again. You could do law of cosines again for angle A or angle C. You could set up this one or this one, right? But do y'all agree law of sines is easier? Do y'all think it's easier? I mean, maybe somebody, you could have a different opinion. I just think for me, proportions are simpler. Yeah. Okay. So I'm going to use law of sines then to find the next missing angle, which it doesn't matter which one you find next. We'll just do A. So I'm going to say sine of angle A is to side A as sine of angle B is to side B. Okay, so when I plug that in, yep. Nope. When you're setting up a proportion, it doesn't matter which one's on the left and the right. The only thing that matters is that the A's are together and the B's are together in the fraction. You could even flip these fractions upside down. You could say A over sine of A is to B over sine of B, because when you do your cross multiplication, that doesn't matter. It comes out the same as long as you keep these in the same direction. You can't flip one and not the other. You would have to flip both. Okay, but yeah, so different ways you could set that up. Okay, so angle A is missing. Side A, the way we labeled it, that's the 12. Angle B, I'm going to put 117 ... because I need to make sure I remember when I plug this in the calculator, I need to use the entire decimal, not the rounded number. Okay, so I'm going to put that ... to remind me. And then side B was the 18. So when I cross multiply and divide, so I'm going to get sine of A is 12 sine of the 117 number all over 18. And then what am I going to have to do after I calculate this? How do I get rid of sine? I'm going to have to inverse. Anytime an angle is missing, whether you're using law of sines or law of cosines, you have to inverse trig to solve for the missing angle. So I'm going to have to inverse sine of all that. Okay, so pull up my calculator. Okay, and I'm leaving that 117 number in there because I'm going to copy and paste that. So I'm going to do this all at once. I'm going to do inverse. Oh, I was on inverse. Inverse sine. And then it's 12 sine of the 117 number divided by 18. So make sure it's in Desmos calculator and it looks like just like it does how we have it written. Okay, and that comes out to approximately, we're going to the nearest degree. What is that? Yeah, about 36 degrees. Do that over. So that rounded to 36 degrees. Sorry, trying to erase that dot. Give me my eraser. Okay, so we've got angle B, we've got angle A. What's the easiest way to find angle C? Angle sum, the triangle sum theorem. Okay, the three angles of a triangle add to 180. Could I use law of cosines? Yes. Could I use law of sines? Yes. But law or the triangle sum theorem is going to be the easiest way because we've used 117 and 36 so far. So I'm just going to then use triangle sum. It's 180. The 180 minus the 117 minus the 36. What's left for that third angle? For angle C. 117 and 36 is 153. So that leaves us 27 degrees. Approximately. Because all of those were rounded, right? These are all approximately. Yeah, if you do law of cosines or law of sines, make sure you're using these full decimals. If you went back and used law of cosines, you wouldn't have to use decimals. That's fine. You would get a decimal, but it would round to 27. And the angles were rounding to the nearest whole number. All right. And that makes sense, right? 27 is across from the 9s. That's the smallest angle across from the smallest side. 117 is across from the 18, so the biggest angle across from the biggest side. And then the middle angle across from the middle side. That should always check out. All right, so tomorrow you're going to have class time to work on those application right triangle trig problems that were added to the Delta Math, the word problems, and finish those up. So your Delta Math will hopefully be done tomorrow in class and you won't have any homework over the weekend. And then remember, Monday I'm out for a golf tournament and you will be working on this, law of sines and cosines. I'm going to leave you practice over this stuff, okay, for Monday. And then you'll have a quiz on Tuesday. We'll review for a couple days, Wednesday, Thursday, go over quiz corrections. And then Friday will be your test. It'll be over the right triangle trig and law of sines and cosines. So everything, all the notes we've taken in Unit 2 so far. That test is next Friday.